Okay, Assalamualaikum everyone. So let's start our class with recitation of Umul Kitab Al-Fatihah. Okay, so this time we will continue about our polymers. Maybe we will also not finish the polymers today. So this is polymer part 3. Okay, maybe we go until part 4 and maybe until part 4 only lah. Next class we finish the polymer. So today, so let's recap first what we have learned before. We learned before about this type of the synthetic polymer. We have this natural polymer, and then we have the synthetic polymer, and under synthetic polymer, we learn about 7 categories, not 7 categories, I mean 7 type of polymers. Number one is what? Number one apa? PET. One is PET. So I classify this thing numbers according to the resin identification code, because we learn about the resin identification code last class. So number 2 is HDPE. Number 3 is PVC. Number 4 is LDPE. And then number 5 is PP. Number 5 is PP. Number 6 is PS, polystyrene. Number 7 is others. Number 7 is others. And when we talk about others, we talk about nylon, and also we talk about the PC, polycarbonate. So at least now you can see a typical plastic that people use in the I mean in everyday life lah. Okay. So all this plastic that you see now, all this plastic, they put under resin identification code. So when you see resin identification code, you normally see the numbers inside this, what we call inside this this recycle symbol, the triangle there. The recycle symbol here mean what? Meaning that you can melt this plastic and reuse it again and again as if it's a new plastic. So that's what does it mean by what we call this 1 to 7 thing. But when I say melting, when I say this thing, what does it mean by this recycle symbol is that you can remelt it again and again. Okay, again and again, and then you put into mold, and then you get a new. So siapa yang ni? So let me Muharramah, let me mute you. Okay. So when I say melt, it doesn't mean like this. It doesn't mean, let me open this thing. Okay, let me see, open this thing. What is your face? Your face is here. Okay. When I say melt, it doesn't mean that you have this. For example, this is polyethylene. Polyethylene pula. LDPE, you can see this thing. LDPE, the what we call the number 4. Number 4, you can see number 4, the triangle number 4 here. When I see melt, it doesn't mean like this. It doesn't mean I have this thing. You can see jauh here. See this thing, and I put this thing. This, it will sort of like. Okay, you see, for example, they are sort of like melting the plastic that is like blackish and so on here, right? So that is not really what we call melting. That's what we call is. Let me take this thing. Why is so far? Wait, so far lah. Let me open this thing. It's quite far there. Let me change a little bit. So far from me. Okay, let me put like that, and then this I make like this, put like that. Senang sikit. Okay, if you see like this a black thing. When plastic become blackish like this is not melting. This already degrade. Okay, so you need to differentiate between melting and degrading temperature. So for example, for melting, you have this TM, they call it TM, melting temperature, and also you have, they are not, cannot see there, so let me move this thing a little bit here. Let me put this thing, and then I put this bottom lah. So it's much easier for you to see. Okay, okay, like that. Okay, and then I put this color. Okay, so easy, right? So you see this melting temperature there, and then also you have what we call the TD. Normally TD lah. They don't call TD, they just call it degradation temperature. Okay, all these 7 things, the PET, HDPE, PVC, LDPE, PP, PS, and others here, they have their own melting temperature. For example, for this thing, this is LDPE. So LDPE here, the typical melting temperature for LDPE is around 100 something. Around the TM here is around 100, maybe around 110 like that lah. 110 to 130 Celsius. But different manufacturer, they use a different formula. So sometimes you can see, you Google, you can see like this LDPE have this melting temperature around 105, 110, 112, 130 like that. It depends on the manufacturer. When you try to open this thing, when you try to testing, when you do this lighter thing, when you have this thing lighter, you can see like you can see the lighter. This lighter or candle, lighter or candle, the temperature that you get from here, if you go to the hottest part, is around 1500 Celsius. 1000 to 1500 Celsius. It seems, wow, it's very high, but it's actually 1000. It's really 1000 like that. You can get the thermocouple, I mean that the sensor, and to check that. And normally when how people check that thing, they have this thermocouple, they put like this thing, and then they have this what we call the sensor, and then they check the what we call the temperature of the flame. So the candle flame or this butane, so because this inside this there are gas, this butane, not gas, is a liquid, a butane liquid. And normally when you do this temperature is 1500 Celsius, roughly like that, 1000 to 1500 Celsius. Yeah, but roughly around 1000 lah, at least 1000. Normally at least 800 to 1000 something, but the maximum normally 1500. Okay, so similar with others, for example nylon here, so that is, so this temperature, the one that you see here, is far higher than the temperature of this melting point. So when you put this and then you put the what we call the LDPE like this, it is just go to the degradation temperature. Is go well beyond this melting temperature. So that's why you see the blackish degradation lah, because this from oil, right? So oil thing is black, right? Similarly with other plastic also, for example nylon, let's say nylon here, they have the TM around 200. Nylon is around 270 like that, 270 to 300 Celsius. And PC polycarbonate have the TM around 280 to 300. Different manufacturer of the nylon or polycarbonate have a different range but roughly is around nearly 300 lah, nearly 300. So that's why if you have nylon and you have PC polycarbonate, when you put it into, that's why nylon, the one that you see last time I show you sudip, right? This sudip nylon, last time I show you the, nampak kan, it show you the sudip sudip saya ada sudip mana dah, tak bawa balik rumah, nanti kena marah kalau tak bawa balik. Okay, so the sudip, normally when people use this as a PA, right? PA polyamide is a nylon. So when you cook something, normally when you cook on the fire in the kitchen, normally it's around what we call 200 something, right? When you put oil and so on, the temperature of your whatever you cook inside the pan or whatever is around 300, around 200, 250 like that. So you use this nylon sudip, nylon sudip in Malay, in English what nylon, what we call?
Spatula.
Spatula. Nylon spatula, because it can resist the temperature of this the scorching temperature of when you boil or what we call, or you fry something on this pan lah. So that's why people use nylon. People don't use this LDPE. So there are reasons when you learn about this, each of this category of plastic, each of type of plastic, they are different characteristic. Each of them have own characteristic. So that's the reason when you go to your kitchen, find any spatula, you go at the back, you see the triangle. Normally it goes either they put 7 or others. Normally it's nylon. Okay, normally it's nylon. So that is melting temperature. So so this what make plastic different than metal and ceramic. So let's now talk a little bit in general about the mechanical characteristic of the plastic before we go what make this plastic different than ceramic and metal. So let's go here, mechanical characteristic of overall plastic. Mechanical characteristic of overall plastic. Okay, plastic is dissimilar, as of course you know, dissimilar to metal or ceramic lah, to metal or ceramic in term of that ceramic is stiff and strong, metal is stiff and strong, but plastic is basically we can say the one of the mechanical characteristics of plastic is that not as stiff and strong lah, not as stiff and strong compared to these two things, metal and ceramic. But because plastic is lightweight, normally plastic is lightweight, lightweight, meaning that it has low density. So even though it's not as stiff as strong compared to the metal or to the ceramic, but by the basis of their low density, okay, if you make everything standardized, if by the basis of their low density, often the stiffness and the strength is comparable to the what we call to the ceramic and metal. Basically when you compare per mass basis lah, because what we call this metal, whatever metal here, even the aluminium is still heavier than the plastic. Okay, but if we compare mass per mass, okay, if we compare mass per mass, this in terms of strength it will be comparable lah. So it's when you compare, you cannot compare just like this, because this just different mass and so on. So if you compare on the basis of their density, okay, often the stiffness or strength is sort of like we can say more or less comparable lah to the metal and ceramic. Okay. And also plastic is also we can say, let's say this thing, plastic also ductile and pliable. Ductile mean this lah, when I pull this thing, you can see right, it's like it become necking. They have like sort of like necking, we call it, when you pull the plastic. So let's say this plastic, and then you pull this thing, you get something like this, like a neck, like this, what we call necking. Necking, when you pull the plastic, something like this lah. Okay, when you pull opposite way, you have this necking, and this necking normally you can also see in the metal, but ceramic no, ceramic is normally brittle, it just break like that. Metal and plastic, you have this ductile properties. So ductile properties, plastic, metal. And also pliable, meaning that you can easily sort of like do like this, right? Look like this, and it make plastic easily to be molded. I mean, you can mold a lot of things using plastic. You can mold plastic into many different shape. Okay, if you have metal, you can also mold this thing. For example, if you want to make a like sort of like strange structure or whatsoever, you can still mold this thing, but you need to heat this into very high temperature. You need to melt this metal first. But plastic, you can melt it at even low temperature and it become liquidy and you can mold easily lah. So plastic is ductile and pliable. Okay. When we talk about plastic mechanical characteristic here, especially it's important to take into account the temperature, because when you have metal or ceramic in everyday use, you don't use this temperature around like 2000, 3000, whatever Celsius. Okay, the max also in the real life you use around what? Around 100 Celsius, 150 Celsius, and so on. Normally for metal and ceramic, nothing happened to them. But for plastic, then it can be melted, it can be this thing. So when you talk about the mechanical characteristics of the plastic, you need to always include the what we call the temperature into the equation, because the mechanical properties of the plastic will change according to the temperature. So the Mach properties is affect the Mach properties of plastic, Mach properties of plastic greatly, to the point that people divided plastic category based on their temperature sensitivity. For example, so polymer or plastic lah. Polymer, because of this thing, temperature relationship, the plastic normally divided the plastic or polymer lah. Polymer divided into two: thermoplastic, and thermoset, Okay, so this is two big division. We have the synthetic plastic, natural plastic, so that's big one. Okay, but plastic also can be categorized based on their influence of the temperature on it. So once they call it thermoplastic, and another one they call it thermoset. One thermoplastic, one is thermoset. Okay, what is the thermoset and the thermoplastic? Thermoplastic here is the plastic that can be melted and remolded again and again. You can melt it and remold it again and again. Okay, so let me put this: melted, remolded again and again. It's like imagine that you have this. The reason why you can do this thing is because in the polymer, polymer is like a chain. Imagine this is chain of the polymer, whatever plastic is a polymer. So there are no sort of like, so this is one chain. This is one chain. This is chain. So you have chain, but you don't have like interaction. You don't have this weak interaction between interchain between this. So for example, between these two, there are interaction, van der Waals or hydrogen bond and so on, but it's not as strong as covalent bond. Okay, what attached plastic with this chain? If you look this chain, you have this. For example, let's say the polyvinyl chloride. You have something, this thing, and then you have this. Let me put color, this different color lah. Polyethylene lah, senang sikit. So let's say we talk polyethylene. You have this C, and then you have ash, and then you have ash, and then you have C, ash, and so on lah. So this backbone, and so on. So this backbone here, this between C and C here is a covalent bond. So it's strong. It take a lot of energy to break this thing. So that's what make the chain here. But between chain, there are no covalent bond. They are just maybe van der Waals or the hydrogen bond, not permanent bond lah, not permanent bond. So because of this, you can when you hit the plastic, this bond, the green one, the one that in green here, the non-permanent bond will sort of like soften. Okay, you can broke this bond and the chain will slide each other. It's like spaghetti lah. You imagine a spaghetti. You make a spaghetti in a bowl. The chain between the spaghetti itself, the one spaghetti itself is strong, but between spaghetti, you can easily sort of like put here and there, right? So it's like that. Plastic is more like that, the molecular structure of the plastic. So that's why you can melt plastic and reuse it again. Because when you melt, you put temperature, this bond, whatever this bond here, will be broken lah. Broken at certain temperature, at melting temperature. But when you remove the temperature away, for example, when you make it cool again, then the bond reform again, crystallize again. So that's why when you melt the plastic, it become liquid, and then when you left it, it become hardened again, and then you can reuse again. So that is thermoplastic. You can melt and remold again and again. And if you look on the top here, whatever we learned before, PET, HDPE, and so on, this, the one that is under resin identification code here, is all thermoplastic. All this, we can say, all this is thermoplastic. Okay, all this thermoplastic. But if you look here, the others here, the others here doesn't mean all the other plastic than the rest of the 6 here. Meaning that I give you the example nylon and PC. But this nylon and PC also you can sort of like melt and remold again and again. But not all plastic like that. Not all plastic like that. For example, this what we call the tire, the rubber. For example, let's say the rubber. So let's talk about Thermoset first. Before I give the example, let's give definition of Thermoset first. The Thermoset, what is the definition of Thermoset? Thermoset, you can see, right? The Thermoset is basically polymer that form. Polymer is a polymer that form irreversible nampak kan? Chemical bond during curing. Later I will tell you what is curing. During curing, and cannot remelted and reshaped again. Okay, what does it mean by this? So now you see the chain here, chain on the what we call on the thermoplastic is like this, right? You see the black chain. So I repeat again here, black chain here. But now in the Thermoset, you have this sort of like the connection here. You have this between the chain, you have this connection. Okay, so this what we call the crosslink. Okay, the term that we use is that when you have the polymer chain, and then they sort of like there are some bridge between them, permanent bridge. It's not like non-permanent. Permanent bridge, we call it crosslink. So because of this crosslink, it make this Thermoset, it change this Thermoset nature. It change the what we call the plastic nature. Okay, so you cannot get this when you hit it, you cannot sort of like break this chain. Okay, so this the black backbone of the plastic itself cannot slide over, and you cannot remelt it. If you sort of like put a temperature on it, heat it thing, it will sort of like go straight to degradation. It will degrade straight away. Okay, so for example, the rubber. For example here, thermoplastic, you see the example before. For example of this is rubber. Example, let me put here. Example is rubber. Okay, we have natural rubber. But we don't talk about this. We have natural rubber. What I want to show here is about synthetic rubber. Synthetic rubber. Okay. Rubber, natural rubber is a natural polymer. Synthetic rubber here is basically the natural rubber. You have something like this. Okay, it's a polymer. You heat it, it melt. So you can sort of like reshape it again and again and so on. That's natural rubber. What I want to focus here under the Thermoset is this synthetic rubber. So synthetic rubber example is like your tire, your car tire like that. So that is not normal rubber. Normal rubber is in the what we call, alamak, tak nampak. You kena bagi tahu If you cannot see, you tell me this thing. Okay. Normal rubber, if you make a tire from it, normal rubber is like getah in the rubber tree. You see the white thing, the milky set tree thing. So that you can mold and so on, and when you heat you can mold again and so on. But the tire, the 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 tire here, the car tire is not, they do something to that, because if they use the natural rubber as a car tire, then when when your tire meet the ground, it will create a friction. So when the car move very fast, the friction will generate the heat, so the rubber will be melted and so on. Then you get this tire that is melted along the way lah. So they do something to that rubber. What they do is that you have this still the same thing, chain, but then between this chain they put sulfur. So between this chain they put the sulfur, meaning that the sulfur, they have this rubber and then they mix with the sulfur. They mix in the sulfur in this at high temperature lah. So so when you mix with the sulfur, so basically you mix rubber. So I take rubber here, and then you mix with the rubber chain. You mix with the sulfur here. So I just draw like this. You mix with the sulfur. Okay, rubber chain, you have sulfur, and then you put this thing. This process is done in the high temperature lah. They put it in the high temperature, high temp. So what happened during this thing? What happened when you sort of like mix the rubber and with the sulfur together at high temperature? Something happened. The chemical reaction happened where the sulfur will sort of like bridging the rubber, sort of rubber chain. So this process is called vulcanization. Vulcanization. Okay. So basically volcanic is basically volcano lah, right? Volcano, or sort of like it's a vulcan here. Vulcan is basically the Roman god of fire lah, or just remember volcano lah. So meaning that this reaction happened during this high temperature when they want to make this car tire. They combine this together. So when you have this crosslink, so meaning that the sulfur will crosslink the rubber chain. When you have this crosslink, this rubber become hard. Okay, it's not like getah sekerap tu. Getah sekerap, if you ever hold it, you still can play around. But when you see your family car go and touch their tire, you will see it's not as easy to sort of like to bend it and so on. It's hard. So one of the benefit of Thermoset is that it's more durable. It have this durable configuration due to this 3D network. So it will improve the lifespan of your car tire. So you use car tire for 2 years, 3 years, 4 years, still the tire is still durable, still maintain its shape and so on. So there are reasons why people make this vulcanize this natural rubber, so that you get this crosslink. Okay. Okay. So that's example of the what we call the Thermoset, the crosslink rubber thing lah. Okay, another example of this Thermoset. Okay, so this one example. So I put this one. Okay, one. Okay, let me go down. How is here? Let me go down. So the second example of Thermoset. We done with the thermoplastic. Thermoplastic you have done past 2 class, and also this one, thermoplastic one. PE, PET, and so on here. All this thing. So Thermoset, we have only one example now. So now we go to the second example of Thermoset. Okay. Okay, second example of Thermoset. I put here lah supaya this. I put here. I do like this. Okay, so I go down a little bit. Okay, the second example of Thermoset is epoxy. Epoxy. Okay, normally epoxy come into 2 part. Normally this epoxy come into 2 part. They call it resin and hardener. Some of you hardener, some of you might have already familiar with this. Those of you who are like to do the DIY project and so on, most often than not you will come across this epoxy. So Allah, panjang jauhnya. So example of epoxy, this thing. So this epoxy, you can see, right? You can see. So that's the name is araldite. So that araldite is just what we call the trade name, only. So there are many type of the epoxy lah. So this epoxy, it come into two thing. Normally you have this what we call the resin and hardener. I don't know which one is resin, which one is hardener. Okay, so the red one hardener. So you can see here, right? I don't know. I don't want to, because this I'm using the webcam, not the camera. So you can see they call it hardener, right? Hardener. You can see, right? Okay, hardener. And this is we call it resin. So normally epoxy, when you have epoxy, wait, let it sharpen. Okay, resin. You have resin. So this, if you look here, fast setting epoxy adhesive. They call it fast setting epoxy adhesive. Meaning that in order for these two, this for resin here and hardener, if they mix together, then the reaction happen. The cross-link happen. Imagine now you have this resin. Resin is basically sort of like this, the polymer itself, and also hardener also there are something lah. Maybe the polymer or non-polymer, whatever. But let's say it's a polymer. Let's say polymer. So when you mix them together, the reaction happen. The reaction happen in such a way that the cross-link happen. So this thing, they will cross like this. Okay, so the hardener and resin will cross-link each other, and that's where you get the thermoset. So for example like this hardener, this one is, kenapa jauh sangat ni? Tak apalah. Okay, so you can see, right? I think you can see. So for example, this thing, this is what? This hardener. So normally this, you see the same, more or less the same volume. So meaning that you need one volume of this, mix it with one volume with this, and then you get the reaction will happen. So the idea ialah, it's like, you put here like this, like that satu. You have this one volume of the thing. Let me zoom this thing. No, I don't want to zoom. I don't know how to zoom. Zoom properties. Let me wait. Properties. Okay. Okay, let me zoom this thing a little bit. Okay, so yeah. Okay, so that is basically the resin part. Okay, so this resin part that I what we call just put there. So in order to make the reaction happen, you need to mix that with the hardener. So because it's this is one epoxy, meaning that you need one volume of this and one equal volume of them, so that the reaction will occur. So you need to put in such a way like that. This is hardener. So you can see most of the epoxy, they come in liquid form. Most of the epoxy come in the liquid form. There are also epoxy that come in solid form, but most is in solid form. So you have that two equal volume. So what you do is that now the reaction not happen yet. You need to mix this thing. You need to mix like this. You need to make like that. Like that. Normally when you deal with the epoxy, it's advisable to wear the glove. Wear the glove, because once it's hardened, when the cross-link happen, it become hardened. So it's as if you get the glue there. Something liquid and then it's hardened. It's a properties of the glue. So if you have your mixture on your on your hand, it's very difficult to sort of like scrap it lah. You need to kikis lah. So for example like this, I do like this, and then if I just left it for a while, it will harden like a glue lah. By itself, hardener or resin by itself is a liquid. It will not set, it will not harden. Ni lah, it will just be like this. So I need to sort of like clean this thing, because if I not clean this thing, then it will be hardened here. Okay, this thing, if you look here, it is what we call fast setting epoxy adhesive, meaning that in 5 minutes it will be hardened. Okay, in 5 minutes it will be hardened. But there are type of epoxy that it have longer life. Okay, This, when it become before it's hardened here, you see here, it's not yet hardened. It's still liquidy. So this is what we call the pot life. The pot life of epoxy. So between this, when it's mixed, we have this what we call pot life. Pot life, mean that the duration where you can sort of like play around. Okay, this is fast setting, mean that, and they say that the pot, not pot life, they don't say pot life lah, but they say it's 5 minutes it will harden. So the pot life is around 5-3 to 4 minutes lah, and after 5 minutes it will harden. When it's hardened, okay, we call it cured. Okay, so this is the when it's hardened lah, hardened. So the process here, all this process, we call it from here to here, we call it as a curing process. So now curing meaning that the reaction happen now. So now if I'm talking here, the reaction happen now. This whatever, this cross-link happening and so on. So it's curing. The curing happening now, and when it's hard, we call it cured. It already cured lah. Okay, when it's still you can play around, then it's we call it pot life lah. So that's example of what we call the epoxy. This epoxy, the reaction is initiated by the chemical reaction. Okay, because you have the hardener, you have the resin, you combine together, chemical reaction happen. So this thing epoxy here, you can sort of like initiate. I can say initiate the cross-link. What you see just now is you initiate the cross-link using the chemical reaction. Chemical reaction. Okay, so that's chemical reaction. But also you have something that you can sort of like what we call you can also initiate the curing process or cross-link process using heat. Okay, sometimes you have the epoxy not without the hardener. You have this thing only, one thing only, and then they said in the packaging, they said in order for it to set, you need to put into the high temperature. So that is type of the epoxy or resin that you don't need to mix together different chemical. You just put into the high temperature, then it will set. So the second method of to initiate cross-link is by heating. And also this thing, even though it's chemical, if I put this into oven, it will set much faster lah. It will increase the rate of reaction. Okay. Next, you can also cure with the moisture. You can also cure using what we call the UV. Meaning that you have something like a resin, and then you have UV lamp, you shine on that, that it become hard. Okay. For example, the moisture. Example of the moisture here. Okay. Example of the moisture is super glue. Super glue is not epoxy. Super glue, this I just give the idea only lah how this happen. Super glue here, this super glue not epoxy, but I just give you the idea how curing with the we can say is, yeah, super glue we can say is no epoxy. Normally when we talk about epoxy, when you have this resin and hardener normally lah, but yeah, you can say super glue also kind of epoxy, but it's not really epoxy, because when you have super glue like this, gam gajah like this, this thing inside the tube is still liquid, but when you put outside, I'm not open yet. Yeah, okay, this is super glue. When I put it outside like this, the super glue, I put outside like this, it will be in contact with the moisture in the environment. So because of that, it will harden. So the cross-link, so we can say it's epoxy also lah, kind of epoxy lah, because the cross-link happen also. The cross-link happen because of the moisture. The moisture kick the reaction happen. So that's why when you use super glue, inside it will not harden, but once you put outside, it will harden. So the moisture here, sort of like we can say moisture kick the reaction forward lah. Okay, so that's about super glue. So all this thing, we call it. So you have epoxy, you have this what we call we learn about this rubber, we learn about the epoxy. So both of this is the they are like epoxy here. You see, if you don't wear glove, testing, if I just left like this, it will sort of like the glue will not be fall off. So I need to kikis my hand. So that's why if you use epoxy, use glove. That's ni lah. Okay. So you have epoxy, you have rubber. Okay. Talking about rubber here, sometimes you see something like rubber but not rubber. So let's say I go number 3. So this under Thermoset also. Silicone. When I said silicone, it's not the silicone in the what we call in the periodic table, because you need to differentiate. Silicone with E is not the same as silicone. Silicone in your periodic table. The periodic table you have silicone, right? And let me open this periodic table. Malah nak buka. Ada ke? Here. You have this PT. You have that you can see, right? Okay. PT table. Okay, so PT table there. So you have the silicone under the metalloid. Okay. Okay, you have this thing. Okay, let me close this first for a while. Okay, so you can see this silicone is here. Yeah, silicone here. The silicone is in this metalloid. So you see the metalloid, right? Metalloid. So this silicone is metalloid, meaning that they have this metal and non-metal properties. And people use silicone to make the semiconductor and so on, because it can conduct and it can also be insulator. You can make a switch of that. So the silicone with E is not this. Silicone is, yes, silicone is element. But when I said the silicone here, under the polymer, the silicone here is basically, you have the silicone, but it's like a polymer. You have the silicone, and then you have the oxygen. You have the silicone, and then you have the oxygen. You have the silicone and oxygen. And then on here, sometimes you, let me put this. And here you have this CH3. It can be anything lah, CH3 or whatever. It's not necessarily CH3. So you have this CH3 like that. So it can be anything, but this thing normally organic lah. We call it the group here, the one that here. It can be any other organic thing. Okay, CH3 or whatever else lah. But this is the backbone. The one that is silicon, oxygen is the backbone. Like a polyethylene, like we learned before, you can see here, right? The CCCC, the one is in yellow, is the backbone. Okay, silicon is like this. Okay, it's like rubber. It's like rubber, but it's not rubber, because rubber is made from the isoprene, so on like this. The rubber is the difference between this and rubber. Rubber, the what called the rubber is like this. Rubber, you have something like this. You have something like this. Isoprene, they call this thing. And then you have something like this. You have something like this. This is the monomer of the rubber lah. The monomer of the rubber. So, and then you have something like this lah, with the N and so on. So, you know, like, you learn about organic chemistry. This is C lah. This is C. This is C. This is C, and so on. You know about organic chemistry. So, this is what we call isoprene. Okay, the rubber is basically, not N, the rubber is basically, you have polyisoprene. Okay, so meaning that this is the monomer of the rubber, the one that you see, that thing. You link it together again and again and again, you get polyisoprene. So that is rubber. So you can see the structure of the rubber and silicone is different, but you can see the what we call this. So this example of the silicone lah, silicone. It's like rubber. It's like rubber. So this is rubber. This is rubber. Let's see, I open here lah. Okay. So later we go here. So this is silicone, whatever lah, silicone. So this is rubber. Rubber is like having this elastic thing. So both of these have elastic properties. And in fact, these two things, rubber and silicone, we can also sort of like they also certain, we can put these two things under what we call, under class, what we call the elastomer, class of elastomer. Elastomer is basically sort of like what we call the polymers that can deform, have high deformation lah. So that's elastomer. Basically the polymer with high deformation, meaning that you deform and then it will return back to the original. Okay, so normal plastic you cannot do that. For example, normal plastic like this polyethylene, you deform it, it just deform lah, it just goes to like that, and then it will not coming back like normal. But rubber like this is silicone, you see the silicone, and you have rubber, they have this high deformation, and it can return back to this normal. So we call it elastic properties lah. They have this elastic properties, reversible elastic properties. I put here elastic lah, elastic properties. It have this high elastic properties. So this is different class of polymer, elastomer. So normally when you talk about polymer, normally people say polymer and elastomer. Normally when sometimes you see that people put this title polymer and elastomer, even though elastomer itself is a polymer, but yeah, this is a, you know that we have this thermoset and thermoplastic and thermoset. You differentiate the polymer based on the temperature, but sometimes people also make a distinction like this in terms of whether it's elastic or not. You have polymer, normal polymer like plastic, and also elastomer. So elastomer is basically special kind of polymer that have this high elastic region, like rubber and silicone. Rubber and silicone. Okay, so that is the thing. So talking about, so now I want to combine this elastomer and temperature thing. We 919. So let's go. Okay, polymer and elastomer. It is all both polymer, and also we also talked before about thermoplastic, and also thermoset. Thermoset. Okay, so now you have this polymer, elastomer, thermoplastic, and thermoset. And now talking about temperature, and the red one, the polymer elastomer, talking about the elasticity or deformation capability. So let's say we want to combine them together. Okay, in the previous class I am talking about I'm talking about the temperature. In previous class, when I talk about the PP, this is in previous class. When I talk about the PP, I talk about the autoclave, I talk about the pressure cooker. Remember that thing, the last class? When I talked about the autoclave, the PP can be autoclavable, and then I have some confusion about the temperature and the pressure and so on. So let's do that again. So if you see any let me go to this, any autoclave, mana? Okay, autoclave or whatever, or pressure cooker, you can see image. I hope you can see. Okay, you can still see. Let me go to this. Okay, you can see here. You can see in the autoclave you have this like blue thing, right? Blue, this red, black thing, this black thing. You see this thing, right? The black thing. So all this is the gasket, and this gasket is made from the elastomer. Okay, because when you have something like this, when you have something that elastic, if you have two surface that is not clean enough, so this plastic, when you push it, it will sort of like filling up the gap, this minor gap. So this autoclave or pressure cookers, you always see they're having this gasket. Okay, we call it gasket. So the reason for that is that, mana saya punya pen ni? Wait, pen ni. Okay, so you have this thing. Sometimes we call it O-ring lah. So you have this black thing or whatever color they want to do it. So when you have the gasket like this, if you have these two surface, to surface. Let's say maybe the surface is seems clean to you, but then under the microscope you can see a lot of pit and trout. You maybe under the microscope you will see there are a lot of this irregularity. Maybe you see something like this under the microscope. Okay, under the microscope. So when you have elastomer, the black one here, so because the properties of elastomer is it can deform, so when you push thing to this elastomer, the elastomer will fill the gap. The elastomer itself will fill the gap between the hole, or sort of like micro hole and so on. So when you fill the gap, then you get the seal. You fill the gap, you get what we call seal lah. So when you hit something 9:22, because I'm looking at the time now. So when you fill the thing, so when you have something like this, when you put something in the what we call, let's say this water, I think easy, I just show here lah. So you have this side, let me make it not zoom yet. Okay, let's say you have that thing, you have this thing, and then you put the water. Set the water. Okay, set the water. So let's say I put the water there. So you can see the water there, nothing happen, right? That the water just stay like this. The reason for this, because I want to come back to this elastomer and so on later on. The reason why the water behave like this on the surface, we look at the surface, because on the top here there are like pressure, the atmospheric pressure that hold the water, so that the water will not escape. So on the surface here, imagine there are like water molecule on the surface here, on the surface, this water molecule on the surface. So this water molecule cannot escape to the atmosphere. It will escape, but it take a long time. So the violent escape happen when you see something boiling. When thing boiling, you see something like bubble, right? So that bubble is basically water trying to escape the atmospheric pressure. So here you have the pressure pushing on the water surface. That's why you see nothing. But if you reduce the pressure, for this, for example, if I put this into the vacuum chamber, so let me make it bigger a little bit. Let me make it bigger like that. Okay. If I put into vacuum chamber, let's say I have this thing, and then I put this thing. I put this water here, and then I put the lid. Let's say this. Okay, so I want to close this thing. Let me make a little bit bigger. I want to close this thing. So in order to close this thing with something, you need a gasket. So this is type of gasket lah. This made from the silicone. So you put there, because if I have this top, so this is the top. So you can see like the top, whatever the top. So this is just acrylic plastic. So if I put like this, and if I bring the oxygen out, the air out, so it will not create a tight seal. So that's why I need to use this gasket. So this elastomer. That's why you put this elastomer here, whatever there, and then you put this thing, and then I will sort of like open the vacuum. So I connect this thing with the vacuum pump. So if I open the vacuum pump, so I want you to see this thing. Let me make it zoom there. Just look at this thing. Look at the water there. So I need to okay. So now the air is sucked out from this chamber. So you can see later on you see there are bubble appearing on this water. Okay, so that thing. So I need to close this thing. Okay. So you can see bubbles start to form, and this is basically happen because now there are no push. Now what happened now? This thing now when you put into the chamber here, and then you have this what we call this thing, and then you have this water, and then I vacuum out. meaning that air out. So now there are no like there are no pressure, there are very less pressure. So the water now start to coming out, not start to coming out, you can see the bubble happening there. So this is a kind of what we call when you remove the pressure. So there are no like something pushing the water surface. The water molecule now can escape easily. So you can see this is uh, meaning that you lower the pressure. Basically you lower the pressure. So when you boil when you do use a what we call the when you use this what we call the pressure cooker, let me stop so you can see that, right? When you use the pressure cooker, what happen is that you induce when you no before. Okay, so now I put the air back, so that's why you can see the bubble is going out. The bubble is slowly coming, really not there anymore lah. So normally when you have a water, when you heat it, it will boil. So the boiling is basically when you see bubble with the temperature. Okay, when you see the bubble with the temperature, but when the pressure is low, then what we call, you can boil the water below the 100 Celsius, because in the normal situation, you go to the kitchen, you need 100 Celsius in order to see boiling, in order to see the water, meaning that boiling, meaning that you have something bubble lah. But if you go somewhere up, for example in the mountain where the pressure is low, as if like inside the vacuum chamber, but not as strong as in the vacuum chamber, then there are less air to push the water molecule, water surface. So that's why when you go to go to the mountain, the pressure is low, and then when you try to heat the water there, you you don't need the 100 Celsius for it to be boiled. Maybe you need only 80 Celsius, then you get the boiling, the same effect, the boiling as at the kitchen. So because at this thing you have the low pressure situation. Okay, now because I need to connect this thing lah. Okay, so today maybe I take another 5 minutes, 5 to 10 minutes because I need to complete this thing first. So when you do in pressure cooker, what happened in the pressure cooker? Okay, you have this pressure cooker. The pressure cooker is different. You have this is pressure cooker. Pressure cooker. Okay, let's say you put water inside. In pressure cooker, you don't remove the air out. You basically, heating the thing. You heat the vessel, and at the same time, you also close this thing. You seal, and also you heat. Okay, so when you heat, the boiling will occur. And then when it's boiling, the water turn into gas. So the gas will escape. The gas will coming out, but the gas cannot escape because this seal cannot escape out. So the gas keep hitting the wall of the inside wall of the pressure cooker. So when you do that, you increase the pressure, because you heat something, you increase the pressure lah. So when you heat the thing, the gas will expand, the steam will expand, and it will increase the pressure. So from the ideal gas law, if you look the ideal gas law, let me put this thing, ideal gas law that we see before, PV equal to nRT, where P is a pressure, V is a volume, N is the amount, R is the constant, gas constant lah, T is the temperature. So here what you do is that when you increase the pressure, because when the steam cannot get out, the pressure increase, the temperature also increase. Okay, the temperature also increase. Whenever you see something like this, the equal sign, what does it mean by the equal sign? Let me make it smaller a little bit. Okay, let me go down. Okay, so when you see something like this equal sign, for example x equal y, so the graph is something like this, right? like this. This is y, this is x. So if x is 1, maybe y is 2, x is 2, y is 4, like that. So meaning that when x increase, the y also increase. So it's proportional. So same with this ideal gas law, you see the pressure increase, the temperature also increase. So what happen when you when you cook in the pressure cooker, you can cook with water. If let's say you put water, the water there will increase the temperature beyond 100 Celsius. Okay, beyond 100 Celsius, because you increase the pressure, the temperature also increase. So if you cook the water inside the pressure cooker, instead of 100 Celsius, because normally water boil at 100 Celsius, right? Water boil at 100 Celsius. This is at, let me make it small here. Okay, water boil at 100 Celsius at ATM, atmospheric pressure. But if you put something, when you sort of like increase the pressure, the one that we see before using this what we call this, the demo that I showed before is basically you reduce the pressure, but now you increase the pressure because you don't allow the gas to escape. What happened is that the temperature also increase. So now instead of having this water 100 Celsius, now you get around 120 Celsius, like that. 120 Celsius. This 120 Celsius you cannot do. Normally you cannot do with water, because water, when you heat, no matter what you heat in your kitchen, it's always stay at 100. Okay? And then after 100 it becomes steam. If you want to maintain the water but beyond 100 Celsius, you need to put into the pressure chamber or pressure cooker. So that's why if you go to the autoclave, if you Google autoclave here, if you go autoclave temperature, you Google the autoclave temperature, you can see here, there you can see like 120C. So the water now become higher. You can boil the water higher than 100 Celsius. You cannot do this in normal situation, but when you put in the pressure cooker, because PV equal to nRT, pressure increase, the temperature also increase, the water will become will heat at such high temperature, 120, 130. So when you have this high temperature, then you sort of like make your food cook easily lah, cook faster lah, because sometimes you can cook faster lah. That's why when you want to cook in the kitchen, when you want to cook in the open kitchen, you put oil. You don't put water, right? You put oil. Because oil, the temperature, the boiling temperature for the oil is much higher than water. That's why when you want to cook at high temperature, you put oil instead of water, because water stay at 100 Celsius only if you open. Only when you close, then you sort of like ni lah, what we call this, make this thing what we call only then you can increase the temperature of water beyond this 100 Celsius. So you might see that this, okay, why we learn this in this material science, right? You might say, oh, this is more like physics, PV equal to nRT. It's more like physics. But they have something to do with polymer. So I will tell you that in the next class, because now it's already 9:35. So I will tell you that in the next class, how this thing, the knowledge about this pressure, chamber, vacuum, and so on, relate with the, what we call the polymer. But for time being, for today, I just want to sort of give you the idea, the interrelation between pressure, temperature, and so on. Okay, so next class, I will continue that. Maybe next class is the last time for polymer lah. Okay, so the question time, just very quick because it's already this. So very quick question time . Question time. Number one. Number one. Saya cakap pasal apa? Tell me about Thermoset.
Afnan.
Thermoset. Okay, Afnan. Thermoset.
Alright, so Thermoset is a polymer that forms an irreversible chemical bond during curing and cannot reshape again after that. So in Thermoset, there is a permanent bridge that makes it is difficult to reshape, which is called crosslink. And the example of thermoset is rubber. And there's two type of rubber, which is natural and synthetic rubber. And the example of synthetic rubber is car tire. And the differences between the synthetic and natural rubber is that synthetic rubber, which is the car tire, is a lot harder and it is much more durable. So when you go and press the car tire, it is harder to press it down. Yeah, it is harder to change the shape of it.
Okay,
So
thank
we
you.
can get the synth. Okay.
Okay,
Okay,
thank
thank
you. We
you.
got the idea that because we need because already time. So now a second question. What is thermoplastic?
Sophia.
Afia, siapa tu Afia yang first tu?
Sophia.
Sophia. Because you just give the name Sophia. Okay, Sophia, faster.
Okay. Thermoplastic, it can be melted and remolded again and again. Example of thermoplastic is the PET, HDPE, PVC, LDPE, PPPS, and nylon and PC. Okay, so between the chain, it don't have a covalent bond, so it will be softened and easily to slide the between the chain. Okay, so it will be broken at melting temperature and it will be when it's cool it will be hardened again.
Okay, thank you, Sophia. So number 3, tell me about elastomer. Elastomer? Anyone? Nuha. Okay, Nuha.
So elastomer, the we usually sekejap. So elastomer, it is not the same with the polymer. Elastomer,
Okay, example of elastomer.
we can use it in the lab to it can it can uh, it can it fit in the gap it fit in the gap it fit in the gap it fit in the gap
What is the example of elastomer?
example
Example.
uh, example
Example of elastomer. Elastomer ni apa? What is elastomer actually? What is the properties of elastomer? You need to answer because if not cannot get What is the properties? You can talk in Malay also.
it polymer with high deformation.
High deformation
Yes.
Okay, elastic. So example of
So example is silicone.
silicone. Okay, thank you, Nuha. Okay, for those 4 here, tell me why. Tell me about epoxy.
Nidal, sir.
Nidal. Siapa?
Okay. Nidal.
Okay. Epoxy.
Okay. Epoxy is have two part, which is resin and hardener, which then when we combine the two, so it will become epoxy, and then the process is the curing, where when the between the time it take to harden, its name is spotlight, where it can be played around, become it is hardened. So after it hardened, the name is called cure. So epoxy, it is to initiate cross line. We have a chemical reaction, which is we have to wait for a while so that the resin and hardener will combine each other to become hardened. And then the second is through the heat, and the third is moisture, for example, super glue. And then the fourth is UV, which is the epoxy most liquid is is the liquid form.
Okay, so thank you, Nidal. So that's it for today because now it's already 9:41. I'm sorry taking 10 minutes of your time. So any question you can ask in the WhatsApp group. So for now, for those who will answer this thing, Nidal, Nuha, Sophia. Sophia, your full name is what? Because I afraid there are two Sophia.
Sophia Izamara.
Sophia Izawara. Sophia, huh? With S, huh?
Sophia Zamara.
Sophia Zamara. Zamara.
Yeah.
Okay. Sophia and Afnan, please check the what we call the class master sheet later on. And that's it for today. Anything you can ask me in the WhatsApp group. Next class is on Monday. Next class will be on Monday. So I will Monday on Tuesday next week. So I will see you that class, and in that class we will maybe end this polymer part. End this polymer part. So I think that's it for today. So I will end our class with station of Tasbih Kafarah and Suratul As.